So we are going to work on setting up trig ratios that then we can go through and actually answer to find the missing value of the triangle. So remember, we're only working with right triangles. We're doing right triangle trigonometry right now. And the other thing that you're going to need is a scientific calculator. I have this one, so I'll show you how this one works. If you have an iPhone, it will work. It's just done in a different order. So if I have time in this video, I will show you that as well. Okay, so we're going to start with this page as a guide, so the triangles are already set out. All right, now, things that you want to remember is our good old, and here's my fat marker again, we want to remember SOHCAHTOA. All right, so those are the trig identities. That's a way to help us remember which one makes which ratio. And then we are going to actually use the calculator then to calculate the answer to these problems. Okay, so first up, number one. All right, so zoom in here. Let's make sure we're good and focused. All right, so starting with this one. So I'm looking at this one, and I have this angle. Now, I don't have any letters on these triangles because we don't really need them. I have this angle right here, and I could figure out what this angle is just by subtracting from 180, but I don't need to. And then I have these two sides, but I'm actually looking for this one right here. So from this angle, I have the adjacent side and the opposite side. So from this angle, it's 25 degrees. I know the adjacent and the opposite. So which trig function am I going to need to use if I know the adjacent and the opposite? That one, the tangent. All right, so the way we write this is the tangent of 25 degrees, because the angle measurement goes there. So the tangent of 25 degrees is opposite over adjacent. So that means x over 12. All right, so just absorb that for a minute. So from this angle, I don't know the hypotenuse. I can't figure it out because I need two sides in order to use Pythagorean theorem. But I know this angle, and from here I have opposite and adjacent, which means I can use the tangent trig function to figure out this side. All right, now, all we want to do here is solve for x. So if you think about what you know about, and I don't have a pencil, but I'll just use this gray one. If we wanted to solve for x, we need to multiply both sides by 12. Okay, so now we're going to grab the calculator and turn it on. All right, now we're going to type this in exactly how we wrote it. So we have 12 times the tangent of 25 degrees. So I'm going to type 12 tangent 25, hit enter, and it looks like I'm getting about 5.6 for the side. So that tells me that side x is about 5.6. So at this point, if I wanted to, I could use Pythagorean theorem to figure out the hypotenuse. All right, number two, here we go. All right, so first thing we need to do is analyze what we know about this triangle. So we have this angle, and again, it doesn't matter what letter angle it is at all. But from this angle, we know the hypotenuse is actually what we're trying to find. And we know the adjacent. So if we know the hypotenuse and the adjacent, which trig ratio are we going to use if we know the adjacent and the hypotenuse? Right, cosine. All right, so here we go. So for this one, the cosine of the angle is, so from angle 31, we need the adjacent over hypotenuse. So that's going to be 12 over x. Okay, so from this angle, we know the adjacent and the hypotenuse. So from angle 31. So cosine of 31 degrees is going to be the adjacent side, which is 12, over the hypotenuse, which is x. Now, I don't know how important it is for you to go through all the lists, but let's just pretend for a minute, okay, and then I'll just tell you how I do it. If we put this over 1, we can multiply the diagonals together, right? So x times the cosine of 31 would equal 12. So to figure out what x is, we need to divide both sides by the cosine of 31 degrees to figure out what x is. Now, the way I think of it is if x is ever in the denominator, I just switch those two. All right, so now this is what we need to put into the calculator. So if you grab your calculators, clear the last one out. All right, so we need to do 12 divided by the cosine of 31. Okay, so here it goes. So 12 divided by cosine 31. Hit enter, and I think we can go ahead and round this one to 14. Normally we go to the nearest tenth, but this one is 0.999, so I'm saying we can say this one is 14. So x equals 14. So we know that the hypotenuse is 14. All right, next one. All right, so again, first thing we want to do is just figure out what do we know. So from this angle right here, we know the opposite and the hypotenuse. So which trig function is going to relate the opposite and the hypotenuse? Well, that's sine. So we need to say that the sine of 44 degrees is, all right, so from this angle, which is the 44 degrees, we need opposite over hypotenuse. So that's x over 48. All right, so to solve this one, we would need to multiply by 48. So we need to do 48 times the sine of 44 degrees. So just like on this one, we would multiply both sides to cancel that out to get x. All right, so here we go. So now grab your calculator, clear that one off. All right, we need to do 48 sine 44. So we can type it in exactly like that. 48 sine 44. Looks like 33.3. So x is 33.3 approximately, because we're rounding here. So this one is 33.3. All right, very good. Moving on. All right, so from this one, all right, so let's analyze what we know. So we know this angle is 67 degrees. We don't know the hypotenuse, so the trig function that doesn't use the hypotenuse is tangent. So we need to use the tangent of this angle. All right, so the tangent of the angle 67 degrees is, the tangent is opposite over adjacent. So that's going to be 18 over x. So this is like the one up here, the previous one. When the x is in the denominator, I just switch those. So what I need to type in is 18 divided by the tangent of 67 degrees. All right, so if the x is in the denominator, we just switch them. This is y, because when we multiply the diagonals, then we have to divide both sides, so it ends up that way, if you like the shortcuts, which most of you do. All right, so let's clear this out. Okay, so we need to do 18 divided by tangent 67. So 18 divided by tangent 67 degrees. Enter, looks like 7.6. So x is 7.6 approximately. So we know this side right here is 7.6. So again, how this helps you is that now we can use Pythagorean theorem to figure out the hypotenuse. And then, we can figure out this angle very easily just by subtracting from 90 for the 67. All right, next up, number 5. All right. So now things are different, but not really that different. Okay, this time we don't know the angle measurement, but we know that from this angle, so from angle x, we have the opposite and adjacent. So that means we're going to use the tangent. All right, so the tangent of x, which we don't know what it is, so it's like x degrees, is, all right, so we have the opposite over adjacent, so 30 over 20, which, you know, we could reduce that to 3 over 2 if we wanted to. The calculator's doing the work, so it really doesn't matter, but, all right, now, this one is going to be done differently, because this time we don't know the angle measurement. So what we're doing is we're working backwards. We're giving the fraction, and we need to work backwards to get the angle. So here's the deal. So let's take a look at our calculator here. So these are, this button I would double click to get the inverse to show up. So if you see the sine with the -1, the cosine with the -1, tangent with the -1, those are the inverse functions. So those are the buttons we use if we don't know the angle, okay? Because normally we would say, I want the sine of 25 degrees. Well, this time we don't know what the angle is, so we're trying to figure out the angle. So whenever we're figuring out the angle, we need to use the inverse one. Now, in this calculator, I just have to double click. If it's written above, remember, then that means you just have to press the second and then that button. So whatever you need to do on your calculator. So, all right, so what we're going to do is we're going to say that we want the inverse tangent because we don't know what the angle is. So the way it's going to look in the calculator is we're going to say the inverse tangent, and then in parentheses, we're going to put the 3 over 2. All right, so that's how it should look once we type it in. All right, so going to the calculator. So again, for this calculator, I just have to double click. So there's my inverse tangent of 3 over 2. Or if you want to put the 30 over 20, it doesn't matter, you'll get the same answer. Hit enter. All right, this looks like this angle should be around 56 degrees. We're not going to do the angle to decimals because it's not necessary for what we're doing. So I'm going to say that this angle should be 56 degrees. So this is 56 degrees. So this angle right here is 56 degrees. All right, so whenever we have a problem where we don't know the angle, if the angle is the missing part, then we need to use this tangent. Okay? All right, number 6. So here we, again, don't know the angle, but from this angle, we know the opposite and hypotenuse. So opposite hypotenuse is sine. So we are going to use the sine of x degrees is going to be the opposite, which is 14, over the hypotenuse, which is 26. So what that means for the calculator is that we need to do the inverse of 14 over 26. All right, so grab your calculators, clear that one off. So again, this calculator, I just click it once, click it twice, it gives me the inverse. So the inverse of 14 over 26. So I'm going backwards. So I'm telling it the opposite and hypotenuse, and it's going to tell me the angle is 33 degrees. So 33 degrees. So we'll go to the nearest angle because we don't need decimals for our angles. All right, number 7. So here again, here's our angle. We don't know the angle, but we know the adjacent and hypotenuse. So that means we need to use cosine. So the cosine of x degrees is going to be adjacent over hypotenuse. And then again, we can reduce this, but we're going to let the calculator do the work. If you want to reduce it to 5 over 8, that's fine. It doesn't matter. Now, what we're going to type in is the inverse cosine of 10 over 16. All right, so grab your calculator. Let's clear that off. All right, so we're doing the inverse cosine. So inverse cosine of 10 over 16. So we're telling the calculator that the ratio is 10 over 16, and that's going to give us 51 degrees. So 51 degrees. So this angle right there is 51 degrees. All right, next up, we have this angle. So let's see if we can plow through these a little faster. So from this angle, we have opposite and hypotenuse. So that means sine. So opposite over hypotenuse. So that means that we need to type in the inverse sine of 7/11. So if we clear this, so the inverse of 7/11, and we get 40 degrees. 40 degrees. So this angle right here is 40 degrees, which again, if this is 40, then now I know that this one is 50. And then I can use Pythagorean theorem to work backwards to figure out the length of this side right here. All right. Okay, moving on. All right, next up. So don't know this angle, but looks like we know opposite and adjacent, so that means tangent. So I'm going to even go further than this. So I need opposite over adjacent, so I need that in the calculator. So the tangent of 16 over 30 is 28 degrees. So x is 28 degrees. So that one is 28 degrees. All right, number 10. All right, so from this angle, opposite and adjacent. So we'll just write it the other way just so you get practice seeing everything. So opposite over adjacent is going to be 15 over 11. So when I go to the calculator, I need to do inverse tangent, opposite over adjacent, hit enter, and I'm getting 54 degrees. So x is 54 degrees. And again, once I know what that is, all I have to do is subtract from 90 to get the other angle. All right, next up. So from this angle right here, I have opposite and adjacent, which means tangent. But this time, I'm back to the earlier ones. I know the angle. So tangent of 38. So opposite over adjacent would be x over 20. So in the calculator, I need to do 20 times the tangent of 38. All right, so 20 tangent 38 is 15.6. So I'm going to say that side is about 15.6. So knowing that, I can use Pythagorean theorem to figure out the missing one. You know, we could also then, like what we were doing previously, we could call this y and set up another trig function right there if you wanted to figure out the triangle that way. But you do have the option to just use Pythagorean theorem. All right, next up. So from this angle right here, so opposite and hypotenuse, so that's sine. So the sine of 42 degrees is opposite over hypotenuse. So that means we need to do 24 divided by the sine of 42. So grab the calculator, clear that away. So 24 divided by sine of 42, and I'm getting 35.9. Oh, sorry, can't see it there. 35.9 for that length. So 35.9 for that one. All right, number 13. So I have this angle, which I know looks like I need cosine because I have adjacent and hypotenuse. So the cosine of 33 degrees is going to be adjacent over hypotenuse. So I need to flip-flop those. So here, I'll just write it here. So it's going to be 17 over the cosine of 33 degrees. I'm kind of running into the next question, but all right, so we need to do 17 divided by cosine of 33 degrees. Looks like 20.3. So 20.3 for the hypotenuse right there. All right, next up, don't know the angle, but I know adjacent and hypotenuse, so this one should be cosine. So The cosine is going to be adjacent over hypotenuse. So remember, I don't know the angle, so I'm going to type into the calculator like this. So clear this off. I need the inverse cosine. 9 over 22. How about 66 degrees? Sorry. Ooh, yikes. Sorry. Had to take a drink. Okay, 66 degrees. All right, almost done. Moving right along. Okay, next one right here. So it looks like I need tangent. So the tangent of x is going to be opposite over adjacent. So that means that I need to do the inverse again. So tangent of 16 over 20 is going to give me about 39 degrees. Oops. So 39 degrees for that angle right there. All right, next up, I know the angle measurement looks like tangent because I don't know the hypotenuse. So the tangent of 43 degrees is, it's going to be opposite over adjacent. So it looks like, to figure this out, I need to multiply these two together. So what we're going to put in the calculator is 24 tangent of 43. So 24 tangent 43. Looks like 22.4, because we're looking for a side, right? Yeah, 22.4. So 22.4. So there we go right there. All right, we're almost done. All right, right here. Don't know the hypotenuse, but I know adjacent. So that tells me I need the cosine. So adjacent over hypotenuse. And I'm running out of room, but what I need to do is switch those two. So I need to do 50. So let's clear this out here. So we need to do 50 divided by cosine of 61. And I got 103.1. So this side is 103.1. All right, last one. So don't know this angle right here. I don't know the hypotenuse, so that tells me I need to use the tangent. And the tangent is opposite over adjacent. All right, so that means I need to do the inverse tangent on the calculator. So inverse tangent of 17 over 12 looks like 55 degrees. So this angle is going to be 55 degrees. So just to take a minute, since this is our last one, since this is 55 degrees, that tells me that this one would be 35 degrees, because those two have to add up to 90 degrees in order to make 180 degrees. And then if we did Pythagorean theorem, we have 17 squared plus, so here, I'll just do it over here. So 17 squared is 289, and 12 squared is 144. So we add those together and we get 433. So this side right here is the square root of 433, which, let's see, let's type that in. It is about 20.8, which is approximately 20.8. So when you find all of the angles and all of the sides, that's called solving the triangle, because you figured out all the missing parts. But again, once you know what one of the angles is, you can just subtract from 90 to get the other one. If you know two sides, you can use Pythagorean theorem. We could have also set up another trig function, and that would have worked the same way if we had done that to figure out the hypotenuse. Okay, all right. Hope that's good practice. And as always, if you need to rewatch the video, please do.